Welcome to this session on solid principles in object-oriented programming. Today, we will explore the 5 essential design principles that make software maintainable, scalable, and extensible. First, let's introduce SOLID. SOLID is an acronym for 5 design principles that help you write better software. By focusing on making our code cleaner, reusable, and decoupled, we can achieve higher quality and more maintainable systems. Our first principle is a single responsibility principle or SRP. The key idea here is that a class should have only one reason to change. This means that a class should only have one responsibility. For example, imagine a class that handles both customer data and sending notifications. It's better to separate these responsibilities into two different classes. This way, each class is easier to maintain and test. Next is the open or closed principle or OCP. This principle states that classes should be open for extension but closed for modification. In simple terms, you should be able to add new features without changing existing code. For example, instead of modifying a class every time a new feature is needed, we use inheritance and polymorphism to extend functionality while keeping the original code untouched. Moving on to the Liskov substitution principle or LSP, this principle tells us that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. If a subclass does not behave as expected when substituted for its superclass, it can cause issues. So, we need to ensure that derived classes maintain the expected behavior. Now, let's look at the interface segregation principle or ISP. The idea here is that clients should not be forced to depend on interfaces they do not use. This means we should split large interfaces into smaller, more specific ones. By doing so, we avoid creating unnecessary dependencies and make our system more focused and lightweight. The last of the 5 principles is the dependency inversion principle or DIP. According to this principle, high-level modules should not be should not depend on low-level modules. Both should depend on abstractions. This promotes loose coupling between components and improves maintainability. In practice, we achieve this by using dependency injection to pass in abstractions instead of concrete implementations. Now that we know the principles, let's look at how to refactor a poorly designed class. For instance, let's consider a user manager class. This class currently handles multiple responsibilities like storing user data, validating it, and sending notifications. We can refactor this class by separating these concerns into different classes. Here's how we can refactor the user manager class to follow solid. We will create separate classes for storing user data, validating user data, and sending emails. We will use interfaces to allow easy extension and dependency injection to reduce tight coupling. By doing this, our code will be more modular, flexible, and easier to maintain. Let's take a look at the refactored code. We now have a user storage class, a user validator class, and an email service class. Each of these classes has a single responsibility. The user manager class uses dependency injection to interact with these services. This is a simple yet effective example of applying solid principles to improve our design. So, what are the key takeaways from today's session? First, remember that SRP helps you separate concerns. OCP encourages you to extend, not modify. LSP ensures that subclasses behave as expected. ISP teaches us to create small, focused interfaces. And finally, DIP promotes loose coupling between components through abstractions. In conclusion, solid principles are essential for building clean, maintainable, and scalable systems. By applying these principles, we can improve our design, reduce bugs, and make our code easier to maintain over time. So, next time you are designing a system, consider these principles to improve the overall quality. That wraps up today's session on solid principles. I hope you found it helpful. Now, I would love to hear your thoughts or answer any questions you might have. Let's open the floor for discussion.